Now that we've discussed vector-valued functions, let's talk about their derivatives and integrals. The first, we can define the derivative of a vector-valued function. Now remember here, this is of a vector-valued function, with r of t being f of t, g of t, and h of t, as we usually define it. And we say dr dt is just r prime of t, which is the limit as h goes to 0 of r of t plus h minus r of t all over h, just like how we would have defined a derivative in Calc 1. This leads us to r prime of t is f prime of t, g prime of t, or mistake there, h prime of t. For vector-valued functions, the derivative gives us a tangent vector. This vector can be used as the direction vector for when we create the tangent line. Because remember, we need a point and a direction vector in order to create a line in three-dimensional space. So suppose we had an r prime of a, and this is the tangent vector for r of t when we want it at t equaling a. And let's provide that r prime of a is not equal to 0. Then we get a very special vector. A very important variation is the unit tangent vector. This t vector, where it's just r prime of t divided by the magnitude of r prime of t. That means the magnitude of this vector here is just going to be 1. Let's do an example. We have r of t equaling this vector-valued function. Let's find r prime of t. Let's find the unit tangent vector, and then find the equation of the tangent line. So if we have r of t up here, then we just need to find the derivative of each component. So what would be the derivative here? Well, we need to use the product rule. So we would have cosine of t plus t negative sine, so negative sine of t. Then the derivative of t is just 1. And this one, we also have to use the product rule. So we would get sine of t plus t cosine of t. And this would be our r prime of t. Now, what would t be? Well, we need to figure out what the magnitude is. So how do we figure out magnitude? Well, we take the squares first. We have 1 squared plus cosine of t minus t sine of t squared plus sine of t plus t cosine of t squared. And the magnitude would be the square root of this. So the magnitude of r prime of t will just be the square root of 1. Luckily, this simplifies out a little bit because cosine squared plus sine squared is just 1. And therefore, also, t squared sine squared plus t squared cosine squared would just be t squared. So we end up getting 2 plus t squared. Now we have a minus here and a plus here. So that's going to cancel out. So we get the square root of 2 plus t squared. A lot simpler, right? And so what is our t vector of t? Well, we just get that it is going to be, let's make it big, cosine of t minus t sine of t all over square root of 2 plus t squared plus, I erased that bit, 1 over square root of 2 plus t squared. Then finally, sine of t plus t cosine of t all over square root of 2 plus t squared. Now we have to find the equation for the tangent line r of t at t equals pi. Well, let's use, since we found it, our unit tangent vector. So when we plug in t equaling pi, we're going to get, well, cosine of pi is just going to be -1, and sine of pi is 0. So we get -1 over square root of 2 plus pi squared. Here, we're going to get +1 over square root of 2 plus pi squared. And here, sine of pi is equal to 0, so we get pi, and then cosine of pi is going to be -1, so we get negative pi over root 2 plus pi squared. And that would be the tangent, the vector, direction vector that we need to use. What's a point on the line? Well, we can use this to find our point on the line and say r of pi is equal to negative pi, and then 0. Now we can construct our line. We have our point, our initial point. So tangent line, I don't know what we want to call this. Let's just call it L of t is going to be equal to our initial point, negative pi, and 0, plus t times our tangent, our unit tangent line, -1 over root 2 plus pi squared, 1 over root 2 plus pi squared, plus negative pi over root 2 plus pi squared, which we can just write it into one little form here of L of t equals and that is our tangent line for r of t when at t equals pi.